Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 2 video on the chapter of mensuration, where I will discuss about the formula of how to find the area, perimeter, diagonal of a square and a rectangle, and based on this formula some applications like how to find the area of 4 walls of a room and what will be the longest object or rod that can be placed inside a room. And finally, based on these concepts, I will solve 4 example problems. So this video is part of the playlist CBSE Maths 7 RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 2 video on the chapter of mensuration. Okay. So what will be the formula of the area or perimeter of a square? Now, if you have not watched the previous part 1 where I have discussed about the basics of what is an area and perimeter of a plane figure, then I suggest that you please watch that video also. Okay. So as you know that the perimeter of a plane figure, in this case a square, will be the length of the boundary, of the plane figure. In a square we know, so ABCD is a square where the length of each side of the square is A units. So the perimeter of the square will be the length of the boundary. Now what is the length of the boundary? It is the boundary is all the sides, that is AD, it is AB plus BC plus CD and AD. These 4 sides makes the boundary of the square. So length of these 4 sides will be the length of the boundary. Now all these are sides of the square. So the length of all these sides are A. So we have A plus A plus A plus A. This is equal to 4A. Now 4A units depending on the unit of the side of the square, we will have the appropriate units of the perimeter. So if the sides are in centimeter, the perimeter will also be in centimeter. Okay. So the perimeter of a square where the length of each side of the square is A units, it is 4A units. Okay. So what will be the area? Now the area of the square is A into A, that is area of the square is side where side represents the length of the side of the square, side multiplied by side, which is nothing but side square. This is A square units. The area of a plane figure is always in square units, where the units can be centimeter square or meter square, depending on whether the length, whether the dimension, whether the unit of the side of the square is in centimeter or meter square. If it is in centimeter, then the area of the square will be in centimeter square, and if the length of the side of the square is in meter, the unit of the area will be meter square or square meter. Now where is this formula coming from, that the area is A into A? It is actually based on the area of a triangle. I am not sure whether you have studied the area of a triangle, even though in this chapter later on we will study about the area of a triangle. So as of now, while I will discuss the area of a triangle, I will then show you that why the area of a square is A into A, that is side square, that is A square, where A is the length of the side of a square. Okay. Okay, so this was about the perimeter formula of perimeter and area of a square. where the square is having the length of each side of the square is a units. So perimeter is 4a units and the area will be a square units. Okay. Now let's see what will be the formula of the perimeter and area of a rectangle. So we are having a rectangle ABCD where the length that is AD and BC is equal to L, and the breadth of the rectangle that is AB is equal to DC is equal to B, small b. So length is small l and the breadth is small b. So what will be the perimeter? So what is the boundary of this of a rectangle? So the boundary of a rectangle will be the sum of all the sides. So we have AB plus BC plus CD plus AD. Now what is AB? AB is the breadth, so we have B, small b. What is BC? BC is the length, so L. What is CD? CD is again the breadth and AD is length. So after simplifying this, we will see we have 2L plus 2B. If I take 2 common, I have 2 multiplied by L plus B. So 2 into length plus breadth is the perimeter of a rectangle, where small l is the length and small b, where small l represents the length of the longer side and or length, and the small b represents the length of the breadth, that is the smaller side. Okay. So you can remember for a square, so we see that for a square the perimeter is equal to 4 times side. Now by side I mean the length of each side of the square, and the area is side into side, or this is side square. So this is the basic formula in the descriptive way of the perimeter and area of the square. Okay. So for the perimeter of a rectangle, we see it is 2 into length plus breadth. So this is, so the perimeter P of rectangle is 2 into length plus breadth. This is the formula of perimeter of a rectangle. What will be the area? The area will be length into breadth. Now again, why it is length into breadth, I will elaborate on this when after discussing the area of a triangle. Okay. So the area of a rectangle is nothing but the length multiplied by the breadth. Now of course the perimeter, the unit of the perimeter, this will be 2 into length plus breadth, this much units, and the units will be either centimeter if the length and breadth are given in centimeter, and it will be meter if the length and breadth are given in meters. Similarly, so this will be the unit of the area of the rectangle, length into breadth, this much square units, where the units, the square units will be either centimeter square if the length and breadth are given in centimeter, or it will be meter square or square meter if the dimensions of the length and breadth are given in meter. Okay. Now one more thing to know is about the diagonal of a rectangle. You know that in a rectangle there are 2 diagonals and each of these diagonals are equal. So BD is such one such diagonal and AC is another such diagonal. Now and AD, the 2 diagonals are equal. So the diagonal we represent the length of the diagonal of a rectangle we represent by small d. So the diagonal is equal to AD, not AD but AC, or it is equal to BD, and this is equal to, from the Pythagoras theorem, using the as you know that in this rectangle this angle is a right angle, so ABC is a right angle triangle. ABC is a right angle triangle, and in the right angle triangle ABC, using Pythagoras theorem, I will have AC square is equal to AB square plus BC square. AC square plus BC square. Okay. So I am doing the calculation on the right hand side. I have in right angle triangle, in the right angle triangle ABC, in the right angle triangle ABC, I have AC square, that is using Pythagoras theorem, hypotenuse square is equal to AB square, that is the sum of the square of the legs or arms of the triangle. So this will be AB square plus BC square. AC square is equal to AB square plus BC square, and AB is B and BC is L. So this is equal to small b square plus L square. So we can say that so this implies that what is AC? AC is the diagonal of the rectangle, and we are representing the diagonal with D. So we have small d square is equal to b square plus L square. So this implies D is equal to square root of b square plus L square. So the diagonal will be square root of b square plus L square. So this formula you must also remember. It is pretty simple, as you know. You can easily, there is absolutely no reason that you must remember this. It is obvious from the fact that ABC is a right angle triangle, and keeping in mind the Pythagoras theorem. So the diagonal is equal in a rectangle. The diagonal is equal to square root of b square plus L square, or it is diagonal is equal to, that is a square root of length square, square of length plus square of breadth. This is the formula. The diagonal of any rectangle is equal to square root of the sum of square of the length and square of breadth. Okay. Now, based on these two facts, based on these results, that is the area and perimeter of a rectangle and square, and as well as the diagonal of a rectangle, we will find the area. We will have the result of the area. What will be the formula for the area of 4 walls of a room? So you can consider that the result of the formula of area of 4 walls of a room as an application of the formula of area and perimeter of a square and rectangle. So we, as you can see in this figure, we are having a room. The room is the corners of the room. As you know that the room is a room has 3 dimensions: length, breadth, and height. So in this figure, the vertices A, B, C, D, E, F, G are the 4 corners of the room. Now, so the length, we are representing the length as small l, the length of this room as small l, breadth of this room as b, small b, and the height of this room as small h. I've already labeled the dimensions in this figure. So AB, okay, so this point, let's say this point is H. Okay, so AB, HC, ED, and FG, these are the heights of the room, and the length is BC or GD or AH and FE, and the breadth is CD or BG or AF or HE. Okay, so what will be the area of the 4 walls of the room? So first of all, we need to identify what are the 4 walls of the room. So 4 walls. Now, so the area of the 4 walls of the room will be the sum of the area of the individual walls, and as you know that, as you can see from this figure, that each wall of the room is a rectangle. It will be a rectangle. Now let's try to identify what are the 4 walls from this figure of the room. So 4 walls are Based on this figure, the four walls are the one wall is the topmost wall is no, the topmost is not the wall. The topmost, please remember that in this room, if you consider a room is basically it has three dimension, length, breadth, and height. It is basically a cuboid. You can consider a room as a solid, not solid, but it has two dimension, length, breadth, and height, and it has six. It has one, two, three. It has six faces. But the four faces are actually the considered as the wall of the room. So the four walls are AB, the rectangle AB GF. This is one wall, and the opposite wall, the wall opposite to the wall ABGF is HCDE. These are the two opposite walls in a room. You know that you must understand that in a room we all know that there are two pair of opposite walls. So one pair of opposite walls in the as per this figure is ABGF and HCDE. The other pair of opposite walls are ABCH and FGDE. So these are the four walls of the room. So the area of the four walls of the room will be the area of this the sum of the area of these individual four walls. So these are the four walls, and all these are rectangles. All these are rectangles. Okay. So area, I am trying to derive the formula for the area of four walls of a room, where the dimensions are L, B, and H. L is the length, and B is the breadth, and H is the height. These are in some units. So the area of four walls will be equal to area of the rectangle ABGF plus the area of the rectangle HCDE plus the area of the rectangle ABCH plus the area of the rectangle FGDE. All the walls are rectangle. Now please note that the opposite walls are of equal dimensions. That is, the length and breadth of a pair of opposite walls are equal. So their area will also be equal based on the formula of area of a rectangle. So we can say that this will be, since ABGF and HCDE, these are the opposite walls, their area will be same. So I can write 2 into area of ABGF plus, similarly the area of ABCH and FGDE will be equal, as they are the opposite walls, and we know that the opposite walls will have the same dimension, that is the length and breadth. So we have 2 into area of, let's say, ABCH. Okay. Now let's see what is the area. So if I take 2 common, okay. So what is the area of rectangle ABGF? So as you can see, AB, length of AB, okay. So it will be area of the rectangle ABGF is equal to AB multiplied by AB multiplied by BG. If you see the rectangle ABGF, then the length, you can consider it as it will be a rectangle, and its dimensions, length and breadth, are H, AB and BG. Okay. And then we have 2 into, what will be the area of rectangle ABCH? ABCH. I can say it will be AB into BC. it will be AB into PC. In the rectangle ABCH, the length and breadth you can consider as the sides AB and BC. Okay. So this is 2 into, now what is AB? AB is H. AB is H. What is BG? BG is this BG is equal to this BG is equal to the breadth of this room, that is, it is B. So BG is B. Plus we have 2 multiplied by what is AB? AB is again H, and multiplied by what is BC? BC is the length of the room, that is L. Okay. So this becomes, this is equal to 2HB plus 2HL. I can take twice H as common. I have twice H, and then it will be B plus L. So as you can see, this is equal to 2 into L plus B, that is L plus B multiplied by H. So 2 into L plus B multiplied by H, where L, small l is the length of the room, small b is the breadth of the room, and small h is the height of the room. So the formula for area of 4 walls of a room is equal to 2 multiplied by length plus breadth, that is length and breadth of the room, 2 into length plus breadth multiplied by height. This is the formula of the area of 4 walls of a room. Okay. The final result that we will study, it is also very important, is that in a room, inside a room, what will be, if you consider what will be the longest distance between any 2 corner of a room. So if you consider this room, let's say if you are inside the room, and if you try to find what will be the length of the longest stick or any rod that can be placed inside the room, then geometrically it will mean that what is the longest distance between any 2 corners of the room. So the corners of the room are the points, as you can see, A, H, E, F, that is the corners of the roof, and also the corners of the floor, that is B, C, H, B, C, G, D, B, C, G, D. And so the longest stick or rod that can be placed inside the room will be the length of the diagonal, of the room. Now what is a diagonal of a room? What is the length of the diagonal of a room? Now geometrically, the diagonal of a room means is the distance between any 2 opposite corner of a room, and those 2 corners should not be in the same face or in the same wall. In this figure, as you can see, in a room there are 4 diagonals, and the length of each of these diagonal is same. That is, the length of a diagonal of a room is the longest distance between any 2 corners of the room, and there are 4 diagonals. If you consider this figure, if you consider this room A, B, C, D, E, F, G, then the diagonals are FC, AD, BE, and GH. And if I assume that the length of these diagonals is small d, then it can be geometrically proved that d square is equal to L square plus B square plus H square, where small l is the length of the room, small b is the breadth of the room, and small h is the height of the room. So the length of the diagonal of the room is equal to square root of L square plus B square plus H square. Now, if you ask me how this formula is coming, that D square is equal to L square plus B square plus H square, let me try if I can prove it. Okay, now, so please try, please see the figure. So the FC is a diagonal. FC is a diagonal. Now, if I join the point, the vertex G and C, I am joining the that is the if you consider BC DG as the floor, BC DG as the floor, I am GC is a diagonal. GC is a diagonal of the floor BCDG. So BCDG is the floor of the room, and the GC will be its diagonal. GC will be its diagonal. So what will be based on the formula of diagonal of a rectangle, we know that GC we know that GC square, the diagonal square, will be equal to the length square plus breadth square of the floor. So it will be I can say BG square plus BC square. That is, BG square is, BG is B, it is the breadth of the room. So this is B square, and what is BC? BC is the length, L square. So considering the floor of the room as a rectangle, the diagonal of the floor GC, we are having GC square is equal to B square plus L square. Okay. Now again consider the right angle triangle. In right angle triangle F, G and C, the triangle FGC will be a right angle triangle where angle FGC will be equal to 90 degree, and FC will be the hypotenuse. FC will be the hypotenuse. So in this right angle triangle FGC, we will have, using Pythagoras theorem, the hypotenuse square, which is FC. So FC square will be equal to the sum of the square of the legs or arms of the triangle, which are FG square plus GC square. So in the right angle triangle FGC, the legs or the arms are FG and GC. Okay. Now what is FG? FG is the height of the room. So this is H square, and we have already seen that GC square is equal to B square plus L square. So now you see, so this implies we have FC is nothing but the diagonal of the room. So small d square is equal to H square is equal to L square plus B square plus H square. So this is how we derive the formula that the square of the diagonal of a room is equal to sum of the square of the length and breadth and height of the room. And the length of the diagonal of a room is also the length of the longest stick or rod that can be placed inside the room. So this concept you must remember. Okay. So these are all the concepts about the area, perimeter and diagonal of a square and rectangle, and how to find the area of four walls of a room and the area of a diagonal of a room. Also, one little thing, we know that for a rectangle, the diagonal is given by square root of B square plus L square, where B is the breadth of the rectangle and L is the length of the rectangle. For a square, the diagonal will be, if you consider the square, BD is a diagonal, BD is a diagonal, and also AC is also a diagonal. AC is also a diagonal. We will have a diagonal for a square. The diagonal, if we if we represent the length of the diagonal of the square as d, this will be square root of, as we know, length square plus breadth square, and since it is a square, it will be length and breadth are same, so it will be a square plus a square. This is square root of twice a square, and this is equal to a multiplied by square root. So this thing, little information you must also remember, and remember that the length of the diagonal of a square whose side length is a units is equal to a into square root of 2 units. So these are all the concepts using which we will try to solve 4 example problems. Okay. So the first problem, the first problem says, so these are all the multiple choice questions. These questions are all framed by me. I hope I have been able to frame the questions properly, and the correct answer will match one of the choice. Let's see. Okay. So the first problem says that a wire of length L centimeter is bent into a shape of a rectangle having diagonal of d centimeter. Find the area in centimeter square of the rectangle. Okay. So there was a wire of length L centimeter which was bent into a shape of a rectangle having diagonal of d centimeter. So clearly we must understand that the perimeter of the rectangle will be equal to the length of the wire. So perimeter of rectangle, perimeter of the rectangle P will be equal to length of the wire. Length of the wire which is given as L centimeter. Okay. Now okay. Now let the length of rectangle be L centimeter and breadth of the rectangle B centimeter. So this implies that if we assume that small l is the length of the rectangle, L centimeter is the length of the rectangle and small b centimeter is the breadth of the rectangle, then the perimeter of the rectangle will be, we know from the formula, it will be 2 into length plus breadth. This is the formula of the perimeter of a rectangle. So this is equal to L. This is equal to L because we know that the length of the wire was L centimeter and it was bent into the shape of a rectangle. So this implies from here we get L plus B is equal to L by 2. Okay. Now we have to find, the area of the rectangle. So we have to find L into B. We have assumed that the length of the rectangle, length and breadth of the rectangle to be small l and small b. So the area of the rectangle will be L and B. We have to find LB. Now what else information we are given? We are given that the diagonal of the rectangle is d centimeter. Now we can also say based on the fact that the length and breadth of the rectangle as per our assumption is L and B, we can say that D, that is the diagonal of the rectangle which is given, will be equal to square root of L square plus B square. This implies D square is equal to L square plus B square. So we have we have these two information or result. One is that L plus B is equal to capital L by 2, and the second is L square plus B square is equal to D square. We are given L and D, capital L and small d are given in the problem. Okay. So using these two information, we have to find L and B, L into B, because L into B is the area of the rectangle. How do we find L into B? Now, note that L plus B square, from the chapter of algebraic identities, I hope you are aware that of the algebraic expressions and identity, you are aware of the formula that L plus B whole square will be equal to L square plus B square plus twice LB. Now this implies what is L plus B? L plus B we have already found to be L by 2. So we have L by 2 square is equal to L square plus B square is D square. So D square and plus 2 into LB. So this implies 2 into LB will be equal to L by 2 square minus small d square, which is equal to L square by 4 minus d square. If I simplify this further, I will have L square minus 4 d square divided by 4. So this is 2 into LB. Now this implies LB. So this implies LB, which is also the area will be equal to L square minus 4 d square divided by 4 multiplied by 2. This is equal to L square minus 4 d square divided by 8. So L square minus 4 d square divided by 8 will be the area of the rectangle, and hence the correct choice will be C. C is the correct choice. So C is the correct choice. So the answer is choice C. Now, if I am doing any kind of calculation mistake by solving a problem, and if I am coming with the incorrect answer, then please feel free and let me know in the comment section. I will appreciate that. Let's see the next problem. The next problem says that the length, breadth, height of two rooms R1 and R2 are in the ratio 12:4:3 and 5:3 square root of 2 respectively. If the longest rod that can be kept in R1, that is in room R1, is twice the longest rod that can be kept in room R2, then find the ratio of heights of R1 and R2. So there are two rooms R1 and R2. The ratio of the length and breadth, breadth and height of the room R1 is 12:4:3, and the ratio of the length, breadth and height of the second room, that is R2, is 5:3 square root of 2. It is also given that the length of the longest rod that can be kept in R1, which is basically the length of the diagonal of room R1, is twice the length of the longest rod that can be kept in R2. That is, the length of the diagonal of R1 is equal to twice the length of the diagonal of R2. Then we are asked to find the ratio of the heights of R1 and R2. Okay. Okay. So the ratio of length, breadth and height of the two rooms are given. Now we will use the basic concepts of ratio and proportion. That is, so since the ratio is given, so let length, breadth and height of R1, that is room R1 of R1, are using the parts of the ratio 12x 12x, I am ignoring the units. I mean, since no unit is given, I am ignoring the units. So, are 12x, 4x and 3x respectively. Also, let length. So, this time to assume the length, breadth and height for of room R1 based on the given ratio, I have used the unknown variable x. Similarly, I will use assume the length, breadth and height of the second room, but using some different unknown variable, that is y. So, length, breadth and height of R2 are, let's say, based on the given parts of the given ratio, it will be 5y, 3y and square root of 2y respectively. Okay. So, now we know that. So, what will be the length of the diagonal? So, length of the diagonal or the longest rod that can be placed in room R1. So, length of a diagonal, length of diagonal R1, length of diagonal of R1, that is room R1, will be equal to square root of, we know the formula is square root of the sum of the squares of length, breadth and height. So, for the room R1, the length is 12x. So, we have 12x square. The breadth is 4x. So, we have 4x square and the height is 3x. So, we have 3x square. So, this is equal to square root of 12x square of 12x is 44x square. Square of 4x is 16x square and square of 3x is 9x square. If I add up all the x square terms, this will be 169x square. 169x square. Now, this is equal to I can say square root of x square multiplied by square root of 169. Square root of x square is x and square root of 169 is 13. So, this is 13x. So, the length of the diagonal of room R1 or the length of the longest rod that can be placed in room R1 is 13x. Oh, sorry, I have no space. So, similarly, we can find the length of I'm sorry, I'm writing little small as there is no much space left. So, length of diagonal of R2 will be equal to square root of 5y square of 5y square plus 3y square plus square root of 2 square. This is equal to square root of 25 y square plus 9 y square plus 2 y square. This is equal to 36 y square and this is equal to 6 y. This is equal to 6 y. Okay, let's see. So, this is equal to 6 y. So, now it is given that the length of the longest rod of R1 is twice the length of the longest rod of R2. So, this implies that 13x is equal to 2 into 6y, because 6y is the length of the longest rod of room of R2, and 13x is the length of the longest rod or the diagonal length of the diagonal of R1. So we have 13x is equal to 2 into 6y. This implies from here we can see that x by y is equal to 12 by 13 is equal to 12 by 13. Okay. So now what will be the ratio of the heights of R1 and R2? Ratio of heights of R1 and R2. So this implies height of R1 divided by height of R2 will be equal to what was, as per our assumption, the height of R1. The height of R1 was 3x. So it is 3x divided by what was the height of R2. Height of R2 was square root 2 into y. So we have square root 2 into y. So I have no space left. So this is equal to so this is equal to as you can see 3 divided by square root of 2 multiplied by x by y, and so this is again equal to what is x by y? X by y we have found to be 12 by 13. So this is equal to 3 by square root of 2 multiplied by 12 by 13. This is equal to I'm really sorry for my congested solution. 3 by square root of 2 multiplied by 12 by 13 is 36 by 13 into square root of 2. So this is there is one actually find the ratio of heights of R1 and R2. The choices are given as fraction. It is not given in the form of ratio, but I hope you will understand. The choices should have been given as 39 is to like this, but I did a mistake. I gave the choices as a fraction, but anyway I hope you will understand. So the ratio, ratio of, in the fraction form, the ratio of height of R1 and height of R2 is 36 by 13 multiplied by square root of 2, which is equal to 36 in the ratio form. 36 is to 13 multiplied by square root of 2. So the correct choice will be B. B is the correct choice. Okay, let's see the next problem. ABCD is a square shaped pond. ABCD is a square shaped pond with side length of x centimeter. Okay. ACEF is a rectangle. ACEF is a rectangle where ADCEF is a field such that AF is equal to CE is equal to 3x. So ABCD is a square pond, and the length of the side of the square pond is x centimeter. Okay, and ACEF is the rectangle where we can see that the side AC of the rectangle ACEF, the side AC is nothing but the diagonal of the square pond, and so one side of the rectangle AC is basically the diagonal of the square pond, and the other side of the rectangle, that is AF and CE, they are of length 3x centimeter. Then it is asking, find the cost in rupees of fencing the boundary of the field ADCEF. So ADCEF, so this part is basic ADCEF. So basically this part is the field. this part is the field, and its boundary, we have to fence its boundary. That is, the boundary is AD plus DC plus CE plus EF plus AF. That is the boundary. So find the cost of fencing the boundary of the field ADCEF at the rate of rupees K per meter. Okay. So first we have to find what is the perimeter of the field ADCEF, and then using the rate of cost of fencing, that is rupees K per meter, we will just multiply with the rate. But remember one thing, that the rate is given as rupees K per meter, and in the dimensions of the pond, the sides and the rectangles are all given in centimeter. Okay. So how do we? So the first task is to find the length AC of the rectangle ACEF. So in square, ABCD, in square ABCD, we know AC is the diagonal, and we know that the diagonal square will be equal to, since ABCD is a square, using the direct formula, that the diagonal is equal to square root of 2 multiplied by the length of the side of a square. So in the square ABCD, AC is the diagonal, so the length of AC will be equal to square root of 2 into x centimeter, since x centimeter is the length of each side of the square ABCD. So we have AC is equal to square root of 2 x centimeter. Okay. So this implies this will also be equal to FE. Since ACEF is a rectangle, AC and FE are the two parallel opposite sides and they are equal. So FE will also be equal to AC. That is equal to square root of 2 multiplied by square root of 2x centimeter. Okay. So what will be the perimeter now? Perimeter of field ADCEF is perimeter of the field ADCF will be equal to AD plus DC plus CE plus FE plus AF. So this is the boundary of the field ADCEF is the field, and its boundary or perimeter will be equal to AD plus DC plus CE plus EF or FE plus AF. Okay. What is AD? AD and DC are the sides of the square pond. So they are x plus x. What is CE? CE is given to be 3x. We have 3x plus FE. FE is equal to AC, and AC is nothing but square root of 2 into x plus what is AF? AF is also given to be 3x. So this is the perimeter in terms of x. So this is equal to, if I simplify, this becomes 2x plus 3x plus 3x, that is 8x plus square root of 2x. If I take x common, I have x multiplied by 8 plus square root of 2. This much centimeter is the perimeter of the field. Okay. Therefore, this implies cost of okay. Now, before finding the cost of fencing the field, we need to find the rate per centimeter, because the perimeter of the field is in centimeter. So first so the rate is given as rupees K per meter. So rate of fencing is rupees K per meter. This implies that cost of fencing for 1 meter is equal to rupees K. Using unitary method, I am trying to convert the rate as per centimeter. The rate is given as rupees K per meter. I need to convert this rate as what will be the rate per centimeter. So the cost of fencing for 1 meter is rupees K. This implies that cost of fencing for 1 meter is equal to 100 centimeter. 100 centimeter is equal to rupees K. So this implies cost of fencing for 1 centimeter will be equal to rupees K by 100. So this implies, now I can say cost of fencing the field will be equal to the perimeter. Its perimeter was x multiplied by 8 plus square root of 2. This is the perimeter in centimeter. This multiplied by the rate per centimeter. This is equal to K by 100. This much rupees. This much rupees. Okay. Okay. So this much rupees. So this is equal to, if I simplify, this is equal to, I can have this is equal to kx multiplied by 8 plus square root of 2 divided by 100. So this is the cost of fencing the field. Kx multiplied by 8 plus root 2 whole divided by 100. So kx 8 plus root 2 whole divided by 100. So choice A is the correct choice. So the answer is choice A. Okay, let's do the final problem, that is question number 4. The length, breadth and height of a room are 9L centimeter, 6L centimeter and 5L centimeter respectively. Each wall has a square window of side length 2L centimeter. Each wall has a square window of side length 2L centimeter. What will be the cost of painting the walls? What will be the cost of painting the walls at a rate of rupees X per centimeter? Okay. The length and breadth and height of the rooms are given. Are given as 9L centimeter, 6L centimeter and 5L centimeter respectively. So the length is 9L centimeter, breadth is 6L centimeter and the height is 5L centimeter. And each of the 4 walls, there are 4 walls, each of the 4 walls has a square window of side length 2L centimeter. So if I consider a particular wall, if I consider okay, so if I consider a particular wall, let's say this is a wall and somewhere we have the square window, and the dimension of the window of all the windows in each of the wall are same. It is a square window where the side is 2L centimeter, 2L. Now okay, So definitely the cost of painting while painting a wall, the window will not be painted. The window will not be painted. So if we have to paint all the four walls, we have to paint all the four walls, but without touching the four windows. So what will be the total area that need to be painted? So total area that need to be painted is equal to area of four walls minus, we have to subtract the area of all the windows, because the window will not be painted, only the walls will be painted. So what will be the total area that need to be painted? It is the area of the four walls minus, since there are four windows, 4 multiplied by area of a window. So this will be the total area that need to be painted. Okay. So now what is the area of four walls? We know that the area of a four walls of a room is 2 into length plus breadth multiplied by height. So 2 into length plus breadth. As per the given problem, the length and breadth of the room are 9L centimeter and 6L. So 9L plus 6L multiplied by the height. The height of the room is 5L. Okay, so this is the area of the four walls of the room minus 4 into, what is the area of each window? Each window is having is a square window where the side length is 2L centimeter. So we know that the area of a square is side square. So this will be 2L square of 2L. Okay, so this is will be the area of the net area of the walls that need to be painted. So if I simplify this is 2 multiplied by 15L multiplied by 5L minus 4 multiplied by square of 2L is 4L square. So this is equal to 15 into 2 is 30 and 30 into 5 is 150L square minus 4 into 4 is 16L square. 150L square minus 16L square is 134L square. Okay, so this is this much centimeter square is the net area that need to be painted. Okay, so now I can find cost of painting the walls will be equal to the net area that need to be painted, that is 134L square multiplied by the rate of cost of painting, which is given as ₹6 per centimeter square. Sorry, in the problem it is given that the cost of painting the walls at the rate of ₹6 per centimeter, but it should be per centimeter square. Okay, multiplied by, so this will be rupees, the net area, that is 134L square multiplied by the rate, that is x. So this is equal to ₹134xL square. Oh, so the choices are also given wrong. What will be the cost of painting the walls at a rate of ₹6 per centimeter square? So definitely the net area is 134L square centimeter square, and the cost of painting, the rate of cost of painting is rupees X per centimeter square. So definitely the cost of painting the entire walls will be 134 XL square. This much rupees 134 XL square. So I did a mistake in giving the choices. In all the choices, the X is in the denominator. It should be the choices should be 130 L square X, 125 L square X, 135 L square X, and 134 L square X. So obviously the correct answer is rupees 134. This is the correct choice, but let me quickly change the given choices. So all these choices will be L square, X, 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 and X. Sorry for the mistakes I did in the problems in giving the choices. So with this, it brings to an end in solving the 4 problems and the theoretical concepts of finding the area, perimeter, diagonal of a square and rectangle, and based on this formula, how to find the area of 4 walls of a room and the length of the diagonal of a room, which is also the length of any length of the longest stick or rod that can be kept inside a room. I hope this video will be beneficial to you in understanding the formula of area, perimeter of a square and rectangle, and how to apply the formula and the concepts in solving some problems. In the next video, I will solve the problems from the textbook of author RS Aggarwal. I will solve the problems of exercise 20A, which is based on the area and perimeter of a square and rectangle, and all the concepts that I have discussed in this video. So please stay tuned for the next video where I will solve the problems of exercise 20A. I will end the video here. Thanks for watching, and until the next video, take care and bye.